This video demonstration will provide a brief overview of the steps required to prepare an unknown sample and determine the concentration of one of its analytes, utilizing the fluorescent properties. In this module, you will learn how to determine and measure spectroscopic properties of fluorescent molecules. The molecular spectroscopy properties can be utilized to make both qualitative and quantitative analyses of micro and macro molecules. The material list includes your known and unknown samples, as well as any other equipment and reagents required in their preparation. A spectrophotometer with absorption scanning capabilities and a fluorometer will be your instruments. This module is divided into 4 parts. You will begin by preparing a set of known standards or dilutions. This will be done for each unique molecule you plan to analyze. In part 2, you will prepare an unknown solution of milk. It is the concentration of riboflavin in this milk sample that you will determine. In part 3, you will use a spectrophotometer to determine the wavelength at which most light for that molecule is absorbed. The absorption maximum wavelength values determined in part 3 will be used in part 4 as the excitation wavelength for the corresponding fluorescent molecules. The resulting data will produce another spectrum in which the wavelength of maximum fluorescent emission can be determined. In part 1, you will prepare a working stock dilution, followed by preparing a set of known standards. Determine the volumes of the known stock solution and diluent required to prepare each of your standards. Your manual will contain information on what the final volumes and concentration of each standard in the set should be. The provided chart will guide you with this determination. Obtain the stock solution of your known fluorescent samples and label a set of tubes. First, fill your labeled tubes with diluent using the volumes determined in step 1. Most likely the diluent is water, but can vary with the molecule of interest. After bringing your working stock to room temperature, prepare the standards using parallel dilution according to the values also determined in step 1. When dilution is complete, cover your samples to shield them from light and set them aside to prepare your unknown solution next. In part 2, you will prepare a 1% milk solution. You will be determining the riboflavin concentration of this sample. Dilute 0.5 grams of dry milk powder into 50 milliliters of water. Allow the solution to mix well. Aliquot 25 milliliters of this prepared solution into a separate beaker and add 75 milliliters of solution A. Solution A is a 1-to-1 mixture of 3 molar acetic acid and 3 molar sodium chloride. Stir for 20 minutes to allow undesired material to aggregate. Filter the sample through a Buckner funnel with a filter to obtain clarified sample. Dilute 5 milliliters of the clarified sample into 100 milliliters of water. This is your final sample and is ready for use. You may be required to prepare further dilutions if unknown sample is too concentrated for the instruments to read. With your samples prepared, part 3 will guide you through the use of a spectrophotometer to determine the absorption maximum of each sample. Power on the spectrophotometer and allow to equilibrate for at least 15 minutes. Using the scan function, scan absorbance in the range denoted in your lab manual. Looking at the absorption spectrum, determine the wavelength at which maximum absorption occurs. This absorption maximum wavelength will be used as the excitation wavelength in part 4. Repeat these steps for all unique samples. In part 4, you will use the fluorometer to obtain emission spectra for your known standards and unknown samples. Power on the fluorometer and allow to equilibrate for 15 minutes. During this time, you may open the software, ensure connectivity, and set up the parameters. Your SOP or manual will provide detailed instruction on how to navigate the system software. For each unique fluorescent molecule, use the wavelength at which absorption maximum was determined using the spectrophotometer in Part 3. Excitation at this wavelength will provide the largest emission response. The instrument will produce an emission spectrum from which you can determine the wavelength at maximum fluorescence emission. The absorbance and emission maxima, coupled with the readings of your standards, will provide qualitative and quantitative data. For each sample you prepared, an absorbance and emission spectrum will be produced. These spectra will be used in your data analysis.